Hello, everyone. So today is webinar 6. Wow, exciting. And it's trigonometry. So mostly I will be focusing on trig equations today, not so much on identities. I have done probably 5 or 6 webinars on trigonometry. So please do watch them if you need more information about trig. But I will start about describing the trig circle. And I mean, you might know about the trigonometric circle already, but it's always worth revisiting, even if you've studied it thoroughly. Okay, so this is the trig circle, but what is the trig circle all about? It's actually just a unit circle. It's a circle of radius 1. And if we draw it, it's a radius 1 placed at the center of the coordinate system of Cartesian coordinates. So that's -1, this is -1. And if we draw a ray starting from the middle at an angle theta, and we label the point of intersection as X and Y, and if we look closer, if we look at this triangle that we've created, because the coordinate of this point, the coordinate of the point A is X and Y, that means in this triangle, this side is equal to X, and this side is equal to Y. By the way, I will copy this into the chat for everyone to see. And if we look at this triangle, now we can write that sine theta is the opposite divided by adjacent, by hypotenuse, of course. And the hypotenuse is 1 because the radius of this circle is 1. And we have sine theta is y over 1, which is just y. And cosine theta is x over 1, which is just x. But that just means that the coordinate of A, of xy, is actually the cos theta and sine theta. The coordinates of this point is simply the cosine and the sine. So we can find cosine and sine of literally any angle just working from the circle. So if this angle is 22 degrees, let's say, then the coordinates of this point would be cosine 22 and sine 22 degrees. That's really nice. It's really easy to understand, hopefully. And there's some special points. The special points, for example, this one. This is 0 degrees, and the coordinates of this point is 1, 0, of course. And that means that cosine 0 is 1 and sine 0 is 0. This point, if we take is 0, 1. And that means that cosine 90 degrees, because this is a 90-degree angle, cosine 90 is 0, and sine 90 is 1. There are some special angles, as you can see here. So what this actually means, that this is cos 30, and this is sine 30. This is cos 45, and this is sine 45, etc. If you take 240, this is cos 240, and this is sine 240. Sine, sine is the opposite divided by hypotenuse. Like if you have a right angle triangle, sorry to go back to the basics. So if you have an angle theta, this side is called opposite divided by adjacent, and this is hypotenuse. Sine theta is opposite divided by adjacent. Sorry, I keep making this mistake. Hypotenuse. And cosine theta is adjacent divided by hypotenuse. Something you should know from GCSE. Okay. Um, apologies. Um, okay, am I still sharing my screen? Can people still see my screen? Yeah, okay, thank you. Right, perfect. Right, so moving on. Okay, yeah, that's better. Right, so just looking at the circle, and you can place have some fun with it if you draw a unit circle in GeoGebra. So this is an amazing tool. If you draw a circle with a radius 1 and you draw a ray starting from the center and go to point C, you find this angle and that and settings, value. Okay, so by moving C, you can change the value of the angle. All right, and 23, if 23 degrees, and this is cos of 23 degrees, and this is sine of 23 degrees, and it works for any angle, and you can check it. You can check with your calculator. So, for example, here. Apologies, I still haven't recovered from my illness. It's been like 3 weeks now. Yeah. Okay, so what this means that cos 20.6547 degrees is 0.9357, and sine of that angle, 20.6547, is 0.3527. Okay. And there's another trick. If you draw a vertical line, from B to D, and you place a point, the intersection point, E, and settings, name and value. And you move point C. The coordinate of point E as it moves along the line is actually tangent. I won't. I've done the proof of this fact several times in the previous webinar, so I'm not going to prove it. I'm just going to tell you. Please keep that in mind. If you draw a vertical line, the y coordinate is the tangent. So if you want to find tangent of 49.9, it's going to be 1.1889. So I like to say that this for your unit circle, this is the cosine theta axis. This is the sine theta axis. And this is the tan theta axis. So it gives you the value of the tan theta. So in this case, tan 49.9334 is 1.1889, approximately, of course, because these are approximations. Well, you can you just follow the link and you have access to everything. The first diagram, I assume it's the first one. It's from the assignment. Okay. And it's going to be on video, so you can always watch the video and screenshot it from there. Okay, so hopefully, do people understand how the unit circle works? On a scale of 0 to 10, do you think you understand how the unit circle works? Please answer in the chat. No, thank you. Good. Okay. Now, from here, because we know that cosine could be found from the x-axis, and the y is the vertical axis, is the sine, we can say that we can talk about quadrants. Quadrants. And quadrants work the following way. If you have an angle, but we know that here, in this circle, x is positive here and y is positive. That's we call it quadrant 1. In quadrant 2, x is negative, but y is positive. In quadrant 3, x is negative and y is negative. And in quadrant 4, x is positive and y is negative. But x is cos theta and y is sine theta. Right? We remember that. And if we draw the quadrants for sine theta is positive in the first quadrant and the second quadrant, and it's negative in the other two. Cosine theta is positive in the first quadrant and the fourth quadrant, and it's negative in the other two. And if you remember that tangent is sine divided by cosine, tangent theta is sine theta divided by cosine theta, then okay. Right. And if we do second. And if we do sine theta and cosine theta, then tangent theta is, of course, well, tan is sine over. So if sine is positive and cosine is positive, then this is positive. If sine is positive, cosine is negative. So positive divided by negative is negative. Negative divided by negative is positive. And negative divided by positive is, of course, negative. So the tan theta has this kind of distribution. So if you say that this is 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, it's the same point here, then for any angle between 0 and 90, all are positive, or sine, cosine, and tangent are positive. I hope that makes sense. And some people use the cast diagram. I'm not a fan, honestly, but cast, C-A-S-T. And A stands for all positive. All positive. And S stands for only sine. Sine is positive. C is only cos. And T is only tan, of course. Tan. Perfect. All right, so now we can talk about inverse trigonometric functions. So we know that, well, maybe you don't know, but we know that a function can only have an inverse if it's a one-to-one function. A one-to-one function is always increasing or always decreasing. So, for example, so only one-to-one functions, only one-to-one functions have inverses. Monotonic functions are one-to-one. Well, continuous monotonic. Well, yeah, monotonic functions are one-to-one. That's enough. That's a strong statement. Yeah, so monotonic functions means always increasing or always decreasing. So that's a monotonic increasing, and this is a monotonic decreasing function. Monotonic increase. Okay, that's not a very good one because actually it has P like this, monotonic decreasing. Let's see. For example, y equals x squared, where x is all real numbers, has no inverse because it's not a monotonic function. Because it's a for two different values of x, it has the same value of y. For x1 and x2, it has the same value of y. So this function has no inverse. But y equals x squared, where x is greater than 0, we're limiting the domain of the function. And now the function starts here, and it is a monotonic function. It is a one-to-one function. So every value of x corresponds to exactly one value of y. x1 corresponds to y1. x2 corresponds to y2. It is a one-to-one function, so it has an inverse. And the inverse function is, of course, f minus 1 of x is square root of x. Is the inverse function for x squared. Okay, so if you look at the sine function, for example, let's start with the sine. It's easier. I think sine function is always easier to talk about. Sine function is anything but a one-to-one function. It's not, because for multiple different values of x, you have the same value of y. So not a one-to-one function, does not have an inverse. So y equals sine x, where x is any real number, has no inverse. But if you limit the function, from minus pi over 2 to pi over 2, minus pi over 2 to pi over 2, now this function does have an inverse. So y equals sine x, where x is between minus pi over 2 and pi over 2, has an inverse. Okay, so now let's delete the extra bit. Let's delete the extra bit, which is not needed. And we can draw the inverse. So this is f of x. So this goes from 1 to -1. So this is y equals sine x. And now we just draw the reflection of this graph in the line y equals x. Y equals x. Not the best drawing, but and this is minus pi over 2, and this is pi over 2. And that's how you get y equals arc sine x. It's the inverse function of sine x. Right? So if y equals sine x, the domain is x between minus pi over 2 to pi over 2. The range is from -1 to 1. Now the arcsine, y equals arcsine x, has the domain -1 x 1, and the range is minus pi over 2 y pi over 2. And let's just sketch it. Y equals sine x, but this function does not have an inverse. We have to limit minus pi over 2 x pi over 2. Ooh, that's not what we need. Less x less pi over 2. So this small section of the graph, that's sine x. And if we draw y equals arc sine x, it's like that. So very, very beautiful. Okay. And just draw a small picture here. Okay, now let's start with arccos. Arccos in a very similar fashion. I'll do it on Desmos. Sorry, I just don't want to waste time. Now, sine x. Well, we need cos x now. Equals cos x. Now, this is not a one-to-one function, so we have to choose a different range. So I suggest we start from 0. 0 and go all the way to pi. Oh, nice. So this is a beautiful one-to-one function where every value of x corresponds to exactly one value of y. And now we can flip that. So draw the line y equals x and change. Let's make it. Can you change? Ah, here it is. Beautiful. You can make it dashed. Very beautiful. And now we can do y equals arc cos x. And would you look at that? A beautiful symmetry. So beautiful. I want to copy that in and actually make another copy and just rotate it. Crop, custom, crop, and rotate. And would you just look at this beautiful symmetry? Okay, So this is cos x, and of course cos x, and this is arc cos x. And it's always true, like f is always symmetrical to the inverse of f. So the function and the inverse are always symmetrical over the line y equals x. So yeah, maths can be fun sometimes. Okay, moving on. Problem one, sketch some graphs. I mean, please don't. Please let the first thing, when you do problem one in your assignment, please let the first thing not be put it into Desmos. Okay, we all know that works. Uh, but that's not what we want for you. Really try. um, Really try to get it without Desmos first. Okay, so tan arctan x. Well, first of all, we kind of need to figure out what x could be. Well, we know that you can't have um, tan. So if you have tan of something, that something cannot be equal to um, pi over 2 plus, well, it can't be equal to pi over 2 because tan pi over 2 doesn't exist. Or it can't be equal pi over 2 plus pk, where k is any number. So it can't be pi over 2, 3 pi over 2, 5 pi over 2, etc. So it can't be that. Okay, but let's remember that arctan, oh, it says I'm offline. Just a second. If you look at the y equals arctan function, so y equals arctan x, you can see that this is a function that looks like this, and it has arctan. Arctan x, y equals arctan x. So the range, why is it so? Okay, range is from minus pi over 2 to pi over 2, and the domain is from well, is any real number. So for arctan x, because it can't be equal to, of course, it's less than. So it will never, arctan x is never equal to pi over 2. As you can see from the graph, yeah, arctan x is never equal to pi over 2. So there are no limitations on x. So the domain of this function is actually any real number, because whatever you put into x, arctan x will never exceed pi over 2. And that's really good. And because we know that arctan is the inverse of tan, these functions are inverses, and we know that the composite function of f minus 1 of x is the same as f minus 1 of f of x, which is just x. So this must equal to x, where x is any real number. So literally, the graph of this function is the same as the graph as y equals x. So it's very easy to sketch. Bam, bam. So that's y equals tan of arctan x. Cool. Now, let's check. Let's check if that is the case. So it is tan of arctan x, and indeed, it is just a straight line, which is beautiful, right? Which is a very, maybe slightly underwhelming, but okay. Now let's do the other one. The other one is more interesting. Arctan tan x. It seems like it's the same thing. We know that this has to be just x. It has to be x, but with limitations. With limitations. Well, first of all, let's understand that tan x, so for x is not equal to pi over 2 plus pi k. So any value is off limits. So we can begin by sketching a graph like this. So this is 0. This is pi over 2. So the function does not exist here. It does not exist here. Oh, does not exist. So that's pi. It does not exist at 3 pi over 2. Okay. Three pi over 2. And it doesn't exist here, minus pi over 2. And minus pi, etc. Minus 3 pi over 2. Okay, so these are the points where the function doesn't exist. Now, for values between minus pi over 2 and pi over 2, well, obviously it is just x. So this is pi over 2, and this is minus pi over 2. But this point doesn't exist. I mean, we draw it like this. All right. There's no value at pi over 2 because you can't. Tan pi over 2 doesn't exist. Okay. The range the range of arctan is obviously from, so range, so this is the domain, and range is from arctan cannot take values um, above pi over 2. So minus pi over 2 to pi over 2. That's a useful thing to consider. Right. So the function is limited within this. But what's going on next? The function is limited here and limited on the bottom. But then we remember one more very important thing, that the period that y equals tan x has a period of 180 of pi. So the function repeats itself every pi. In other words, tan of x plus pi is the same as tan x, or tan x plus 2 pi is equal to tan x. What does that mean? Well, that means that every pi, the function should repeat itself. The tan function should repeat. And we can see that from y equals tan x, y equals tan x. You can see that the function does repeat itself. But if the function repeats itself, then arctan of tan must also repeat itself. Arctan of tan must also repeat itself. So it's going to be like this. And then again, That's absolutely fascinating because tan of x plus any number of pi's is equal to tan x. And that means that arctan of tan, yes, I'm using radians instead of angles. Yes, that's the standard. Uh, we'll mostly be using radians because in calculus you can't use degrees. If you're doing a derivative, you're not allowed to use degrees, and that's why we use radians. Tan of x plus pi n is going to be no, I mean if you want to do it in degrees, and if it's not calculus, then you can use degrees. Okay. I'm happy for you to use degrees as well. It doesn't really matter. For equations, it definitely doesn't matter. Arctan tan x plus pi n, and it's going to be arctan tan x, and that's how we get there. And so now we can finally do arctan tan x, and you can see that beautiful graph unraveling in front of our eyes. It's just, yeah, okay. So for this graph, it's very important to understand the domain and the range. Okay. Now I've got 6 more questions. Yeah, that's very. Oh, actually, no, I think there's more. Oh, definitely. There's 7 more questions. So I just move them down. And let's just well, the standard results are in the assignment. And the main difference of our assignment from an assignment from your school is that the range, the domain, is typically not limited. Okay. So, for example, at school, where if they ask you to solve sine x equals 1/2, they will tell you that x is between 0 and, well, 360. Right? Okay, let's do it in degrees first. In degrees. And then you draw a circle and you work out that sine is positive in these 2 quadrants. So this is pi over 6, sorry, 30 degrees and 150 degrees. And you write down the answer. X1 is 30 degrees and X2 is 150 degrees. But what you've done, if you draw y equals sine x and y equals 1/2, you've only found 2 values, these 2, because you've limited, but there are multiple values. The values don't stop. There's infinitely many solutions. But uh, only 2 solutions in school. So at COMPOS. At COMPOS, we do it slightly differently. We say that sine x equals 1/2, but x is any real number. That means you need to find all the values. And this question, should we include the arrows on the bounds? You can. It's not a big mistake if you don't. Okay. But I do advise you to add at least not an arrow, but a dot, a circle at the end that indicates that this point is undefined. Because technically at pi over 2, you have two different values of, well, at pi. Oh, no, at pi over 2, you have two different values of y. We say x is any real number. So what you do here, if you draw that, you say, well, that's 30 degrees, but it's not just 30, it's 30 plus 360 as well. And it's 30 times 360 times n, where n is any number, any integer. And this value is 150 plus 360n. So you could say that x is 30 plus 360 degrees times n, where n is any whole number. Or x is 150 plus 360n, where n is any whole number. These two can be combined together into a single line. Combined. And I really like this combination. So it looks like this. X is minus 1 to the power n multiplied by 30 degrees plus 180 degrees multiplied by n, where n is any real number. Why does that work? Well, let's just start listing the solutions. So here, the first solution is 30. So when n equals 1, it's 30 degrees. When n equals 2, it's 390 degrees. When n equals 3, it's no, z is a whole number. So we have natural numbers. N is natural. Z is whole. Q is rational. R is real. Real. And C stands for complex. And it looks like this. So we have natural numbers, whole numbers, rational numbers, real numbers, and complex numbers. Complex numbers. So any natural number is a whole number. Any whole number is a rational number. Any rational number is a real number, and any real number is a complex number. Yes, z is often we often say that small z is a complex number. But in this case, we say small n belongs to the complex numbers z, is whole numbers z. Okay. Whole numbers. So you can't say n belongs to small z. That doesn't make any sense because n becomes z. It's a whole, so n is a whole number. If n is 2, that's 720 plus 30 is 750, etc. Now here, if it's 150, so if n is 0, it's 150. If n is 1, it's 360 plus 150, 510 plus 360, it's 870, etc. But if we look at this one, so if n is 1, so if n is 0, this is just 30 degrees. If n is 1, so it's minus 1 to the power 1, so that's minus 1 times 30 times 180, so it's 150. If n is 2, we say, if n is 2, then it's going to be 390. If n is 3, it is 510. If n is 4, it's 750, and so on. So you can see that this combines both of these. So these are equivalent. So in general, if you want to solve general formula, if you have sine x equals a, where a is between -1 and 1, then x is -1 multiplied by to the power n multiplied by arcsine a plus pi n, where n is any whole number. That's how you should write your answer. So example, sine x equals square root of 3 over 2, and then x is -1 to the power n, arcsine of square root of 3 over 2 plus pi n, where n is any whole number, and arcsine root 3 over 2 is pi over 3. Pi over 3 plus pi n, where n is any whole number. Ta-da! For cosine, if you have cosine x, it's slightly different for cosine. Because for cosine, when you solve, it's always these two, or the other two. So this would be, I call it arcsin, arccos A, and this is minus arccos A. So if cos x equals A, angles in the general formula, yes. Sorry, I've switched to radians. In radians. I was doing the example in degrees, and then here the general formula I switched to radians. So hopefully the transition wasn't too hard. So cosine x equals a, and a is again from -1 to 1. Then x is plus or minus arccos A plus 2 pi n, where n is any whole number. And for tan has a period of pi, which is 180 degrees. So it's always this and the opposite one. So if this is x, then this is x plus pi. And therefore, if you have tan x equals a, and now a is any real number, then x is arctan a plus pi n, where n is a whole number. Beautiful. So that's how you can solve. And let's do some examples. So here, example. Okay, I'll do 2 examples in degrees as well. Right. Yes, I'll do formula in degrees thing. All right, I'll do that. So if I copy that in degrees, And all we need to do is change that, change those values. Arcsine A plus 180 multiplied by n. Here it's plus 360 multiplied by n. And here it's 180 multiplied by n. So not a massive change. And let's do an example. Cosine x equals 0.2. So x is plus or minus arccos 0.2 plus 2 pi n, where n is number. And you can leave the answer like this because you don't know what arccos 0.2x. So this is an acceptable answer. Or if you want to find the arccos over 2, so you find arccos 0.2, and it's 1.369. X is plus minus 1.37 plus 2 pi n, where n is any whole number. Okay. Tan x equals 3. X is arctan 3 plus pi n. Simple. That's it. And of course, you can do the same in degrees, but it's not different. It's the same. I really want to move on, so I've done almost an hour on theory. So let's do some practice. Yummy. Some excellent. So the first three equations are quite simple, and here we have a fraction. We have a fraction that is equal to 0. In order for a fraction to be 0, two things have to happen. Well, first of all, the numerator has to equal to 0. 3x must equal to 0. But the denominator, sine x, must not equal to 0. Now, we look where sine x is equal to 0. And sine x, because this is sine x, this is cosine x. Sine x is equal to 0 at 2 points, here and here. So this point is, so because y is sine x, so y equals 0 at this point and this point. And this is 0 degrees. And this is pi, 0 and pi. But it's not just 0, it's 0 plus 2 pi n. And this is pi plus 2 pi n. But if you think about it, if you start from here, 0, then the next value is pi, then another 2 pi, then 3 pi, then 4 pi. If you go this, bam, 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 you're just adding pi every time. So it's just actually equal to pi n. So that means that 3x must equal to pi n, where n is any whole number. On the other hand, x must not equal to pi k, where k is any whole number. I'm not using the same one because they are independent. It's a different value, k. In other words, x must equal to pi n over 3, where n is whole number, but x must not equal to pi k, where k is any whole number. What does that mean? Well, let's start listing. Let's start listing the values that are appropriate. So this is pi over 3. Oh, so 0, pi over 3, uh, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, etc. But it's not equal to 0, pi, 2 pi, 3 pi, etc. So we have to cross out the ones that are here. So this doesn't fit, this doesn't fit, this doesn't fit. So how we can do this? Well, there are some clever ways of writing it down. The easy way, easy, is we just say x is pi over 3. And you can see that this one is adding pi. Yeah, plus pi, pi k, and or x is equal to 2 pi over 3 plus pi n, where k is any whole number and n is any whole number. So this is this combination, or so harder. You can do it's pi over 3 multiply. Oh, okay, so I'm not gonna do that. That's fine. This is the answer. Answer. Okay, cool. So I hope that makes sense. Hope that makes sense. The next one. The next one is a product of two functions. So sine times cosine. So that means that sine of x squared minus 4x equals 0, or cos x plus 1 equals 0. So where is sine equals 0? Well, sine equals 0 into these 2 points here. So this is pi k. So x squared minus 4x equals pi k, where k is any whole number. Whole number, so x squared minus 4x minus pi k equals 0. That's a quadratic equation. We can complete the square. X squared minus 4x plus 4 minus pi k equals 0. X minus 2 squared equals 4 plus pi k. X minus 2 is plus minus square root of 4 plus pi k. X is 2 plus minus square root of 4 plus pi k. And, well, you can obviously see some limitations on k, because if k is less than negative 2 or less, then this square root is going to be negative. Therefore, k is any whole number, but k has to be greater or equal -1. Yeah, because if you substitute -2, you're going to get a negative number. Okay. And now that's the first solution. And the second one, so cos equal to 0. Cos equal to 0 are 2 points, these 2 points. So that's pi over 2 plus pi, 3 pi over 2. So it's pi over 2 plus pi k. If you think about it, pi over 2 plus pi plus another pi plus another pi. So that brings you all over. So x plus 1 is pi over 2 plus, sorry, pi n. Let's use pi n not to mix them together. Plus pi n, where n is any whole number. So x is pi over 2 minus 1 plus pi n, where n is any whole number. So this is the second answer. Yeah. And there are no limitations on n. Hope that makes sense. Hope that makes sense. The next one. The next question can be done in different ways. Well, so what can we do? I think the easiest, uh, yes, but k is a whole number, Dhruv. K is a whole number, so it can 4 over pi is minus 1 point something. Okay, so looking at this, sine x plus cos x equals 1. Sorry for my handwriting. Now, sine x plus cos x equals 1. So how would we do this? Well, there are various ways. You could sort of cheat and just draw y equals sine x plus cos x, and then equals to 1, right? So y equals 1. And you could find those values. But what's interesting here is that sine x plus cos x actually looks like a cos graph or the sine graph, or kind of a combination of the two. So let's try to draw y equals r multiplied by sine x plus a, and we add sliders for r and a. And you can see that changing r obviously changes the amplitude. And we can match it with this one. And a obviously moves the graph horizontally because it's a horizontal transformation. Ooh, would you look at that? The graphs are the same or almost the same. So you could say that sine x plus cos x is approximately 1.4 sine x plus 0.8. Would you? That's quite interesting. Well, as a matter of fact, it's not exactly that. Actually, for reasons, sine x plus cos x, and unfortunately I don't have enough time to prove it. It's square root of 2 sine x plus where did we get 0.8? I'm assuming it's pi over 4. Pi over 4. Let's check that this actually works. Y equals square root 2 sine x plus pi over 4. And ta-da, it's exactly the same. It's not just it's absolutely exactly the same. They're identical. Yeah, so that's one way of doing it. Of course, you probably don't know this method, how to do this, but it is a method. And then you can say, well, square root of 2 sine pi x plus pi over 4 equals 1. So sine x plus pi over 4 equals 1 divided by square root of 2. And using the formula that we've previously discussed, x plus pi over 4 is minus 1 to the power n arc sine 1 over root 2 plus pi n, where n is any whole number, x plus pi over 4 equals minus 1 to the power n. This is pi over 4 plus pi n. N is any whole number. And then you can x equals minus pi over 4 minus plus minus 1 to the power n, pi over 4 plus pi n. N is any whole number. And you can just start substituting. So if n equals 1, no, n equals 0, this is minus pi over 4 plus pi over 4, so it's just 0. 0. If n is 1, it's minus 1, so minus pi over 2 plus pi, which is pi over 2. If n is 2, it's 0 plus 2 pi, which is 2 pi. If n equals 3, that's minus pi over 2 minus pi over 2 plus 3 pi, which is 6, 5 pi over 2. Let's check if that makes sense. Y equals 1. So 0, pi over 2, 2 pi, 5 pi over 2. 0, pi over 2, 2 pi, 5 pi over 2. Brilliant. I've got it. Oh, well, for this particular question, this method, you don't know how to do. I'm just showing you if you knew how to prove that, and this is in your A-level course, by the way, so you won't get there. So if you, the other method, so this is the method 2. Let's call it method 2. Method 1 is much easier. Method 1. 1, I'll just square both sides. The good old squaring both sides. So sine x plus cos x squared equals 1. And then sine squared x plus 2 sine x cos x plus cos squared x equals 1. And you remember that sine x plus cos x is actually 1. So that's 1 plus 2 sine x cos x equals 1. 1 cancels, and you got 2 sine x cos x equals 0. And here you have sine x equals 0 or cos x equals 0. There's a catch. Because if sine x equals 0, cos x must be positive, right? Because if sine x equals 0, then cos x must be 1. So cos x must be 1. It can't be minus 1. So that's important. And if cos x equals 0, then sine x must be 1. Equals to 1. So we solve them. We solve these. So sine x equals 0. That means x is, well, if you draw a circle, sine x 0 is here and here. It's pi k, but cosine x is only equal to, so here x is pi k, but cos x equals to 1 only at this point, which is 0 plus 2 pi k. So it's x is 2 pi k. And therefore, we just discard this one. So we leave this answer. So x is 2 pi k, and that's your first answer. For the second one, cos 0 is 0 and sine. So here, cos is 0 at these 2 points, but sine is 1 only at the top. So yes, No. And that point is pi over 2 plus 2 pi k. So x is pi over 2 plus 2 pi k. And let's check that we do get the same results. So here x is 0, 2 pi, 4 pi, 6 pi, etc. And here we get x is pi over 2, 5 pi over 2, 9 pi over 2, etc. And it does work. It is the same results. 0, pi over 2, 2 pi, pi over 2, etc. Okay, moving on. We dismiss the bottom of the circle because if sine x, so if cosine x is 0, that's not enough. If cosine x is 0, then sine has to be 1. At the bottom of the circle, sine would be minus 1, so we're not allowed that. Why do we get this? Well, because when we square, we get extraneous roots. Extraneous roots appear when we square. Square. Right. So we have to dismiss some of them. So that's why. So that's why this method is not ideal. Squaring is not the best method. Because yeah, because you sometimes get extraneous roots. Now the problem 3 is and more interest is an interesting one. You can square again. So sine squared x plus 2 sine x cos x plus cos squared x equals 1.5 squared, which is 2.25. So we get 1 plus 2 sine x cos x equals 2.25. Now we get 2 sine x cos x equals 1.25. Now, it seems like it's much harder than the previous one, but actually it's a lot simpler if you remember that this thing is sine 2x is 2 sine x cos x. So it's sine 2x equals 1.25, but sine 2x must be less than or equal 1. It's not possible for sine to be 1.25. So not possible. Well, so no real roots. So that's the answer. No real roots. Ta-da. That's it. Let's look at this one. Cos x equals x minus pi over 2. Well, this can't be solved algebraically. You just need to draw. You need to draw the graph. Well, so you draw y equals cos x, and you draw y equals x minus pi over 2. So y equals cos x, that's 1, and that's pi. Okay, so that's y equals cos x. So that's pi over 2. And this is minus pi over 2. And then there's this graph, which is x minus pi over 2. So it's something like this. And you can see it's only one point of intersection from the graph. It's a very obvious one. Only one point of intersection. One point of intersection. So y equals pi over 2 is the answer. That's it. Oh, sorry, y. Why did I say yx? Of course, x is pi over 2. That's the only point where they meet. Okay. This one. Okay. What would be a good approach here? Well, you've seen a similar one before. So cos x plus sine x equals 1. And you saw that this is only true when either cos x is 1 or sine x is 1. And this is obviously the case here because cos to the power 9x is less than or equal 1, and sine to the power 5x is less than or equal 1, and greater than -1, greater than -1. So it's equal to 1 just trying to yeah. So if cos x equals to 1, then sine x equals to 0. Therefore, cos x equals 1 is a solution. If cos x equals to 1, then we draw the circle, and it's the only point is here, and the point is 2 pi k. So x is 2 pi k. Now, and similarly, if sine x equals to 1, then cos x equals 0, and therefore sine x equals to 1, which is the only point is here. So it's pi over 2 plus 2 pi k. So x is pi over 2 plus 2 pi k, where k is any real number. Any whole number. Okay. How do now what I'm having trouble with is showing that there will be no more solutions. Um, yes, I think I can explain why. Look, we know that cos squared x plus sine squared x equals to 1. Okay? Now, if cosine x is not equal to 1 and sine x is not equal to 1, then because it's a number. Oh, yes, well, I'm trying to explain why. So we know that this is true, right? But this is always true. Always true. Now, if this is not equal to 0, and this is not equal to 1, and this is not equal to 1, then cos, what's it? Cos 5, cos 9, cos to the power 9x will be less than cos squared x. Because if you take a small number to the power 9, you get a smaller number as if, well, they're both less than 1, right? So if this is true, then this, okay, as cos x is less than 1. And um, sine to the power 5x is less than sine squared x, as sine x is less than 1. That means, hence, sine to the power 5x plus cos to the power 9x is strictly less than sine squared x plus cos squared x. And that means sine to the power 5x plus cos to the power 9x is less than 1. So it cannot be equal 1. So sine 5x plus cos 9x cannot be equal to 1 if sine x is less than 1 and cos x is less than 1. Therefore, you can't have decimals. You can't, you can't, yes. So it's only true, equation only works when sine x equals to 1 or cos x equals to 1. Oh, that's a beautiful, this is the kind of maths I enjoy. You have to really think about it. You have to really try to understand what's going on here. And well, cos can be 1/2, but 1/2 to the power 9 is 1 over 512, right? Yeah. And even if cos to the power 9x is 1/2, then cos x is 1 over 9th root of 2, and that means x is, well, it's almost 0. No, it's almost 90 degrees, and that means that sine x is almost 0. Therefore, sine x, by no means sine x would be 1/2. Hope that answers your question. There's two reasons. Well, first of all, if cos x is 1/2, then to the power 9, it's going to be 1 over 512. Unfortunately, I don't have time to do the last one. Sorry, but okay. I hope this was useful. I hope I didn't. I hope you didn't lose me halfway through. And I'll see you all in 2 weeks' time. And yes, so I'll see you, and good luck with the assignment. Enjoy. Yes, the recording is on the website. If you go to our website, you press webinars, and all year 12 webinars. That's where you can find all the recordings. Oh, here we are. Oh, that's not what I expected, but yes. Okay. All right. See you. Oh, I'm not sure. Look at when is it due? I don't remember. End of this week, perhaps? No? Look at the paper, at the assignment. Either way is good. Better to write your answers as two equations or combine, doesn't matter, as long as it's correct. All right, see you.